So up until now, we've been using primitives. They are a single thing in a single box. And in reality, that's not what usually happens. So today we're going to start and we're going to talk about these things called arrays. And an array is a way of storing related information in a single variable, but there are several pieces of data. So a lot of people look at them like it could be like this thing, a picture with boxes. Some people look at it like a variable is like a memory in like a file drawer. And if you take out a file folder and you have like several dividers, it could be like this. Some people look at it like an Excel spreadsheet. It's like a row in an Excel spreadsheet. However you want to mentally look at it, it's just this variable name, student marks, can actually hold several things. Now, here's the weirdness. Once again, in computer science, we start counting at 0, and this is why we start counting at 0. And if you take grade 12 computer engineering, why we start counting at 0 and how memory is actually allocated in a computer, you'll learn why. Okay? So when the computer allocates this memory student marks and there are 5 things, it actually has to reserve 5 slots in memory for this. Okay? So what it does is it creates a pointer to the beginning one, and then it references off of that. If you say student marks, I want the 0th one, it just goes to that spot. Okay? If you want the next one, it references the beginning and then hops over 1. If you want this one, it goes to the beginning and then hops over 3. Okay? So this, it goes there and hops over nothing. That's what's happening. So that's why we always start counting at 0 in computer science. This is the 0th element, the 1st, 2nd, 3rd, 4th. In total, we have 5 items. This is going to be something you're going to trip over continuously. The difference between how many items I have and how I reference the item. You're going to get this error called index overflow or something. If you try to say student marks number 5, there is no 5. And it's going to try to reference that and it's going to be like, ooh, that doesn't exist. I'm going to stop and crash your program right away. Because in reality, there might be some other variable there. And if the computer actually lets you reference student marks number 5, then you're going to get back something that isn't your data. Okay? So just be warned about the difference between how many there are and the piece that I am picking out. This is the 2nd one, even though it looks like it's the 3rd one in the list. Okay? So 0th, 1, 2, 3, 4. So we can declare a variable and we can actually save several items into it. Okay? Depending on your programming language, referencing it is usually done with square brackets. It's actually pretty universal. Virtually every programming language uses the square bracket. Okay? So saying student marks the 3rd index, we are talking about this one here, 84. So if you use the variable name, brackets, and a number, you're actually picking out a single element. If you're using just the name, you're traveling around the entire collection. Okay? So you can do those 2 things. You could pass around the entire collection, or you can say, I just want to pick out a single one of them. So now that we know how to use it, in virtually every programming language, you have to let the computer know this is what you're doing instead of a primitive in advance. Particularly languages like C that are compiled, you have to, in your declaration section, say, hey, I'm going to create this variable, and it is going to hold 5 items so that it can reserve that space in memory. So in C, we would do something like this. Okay? We would say it's an integer, it's called student marks, and there are 5 items in total in there. Notice the type is there. All student marks are of type integer. Not all programming languages are like that. Python, for example, you can put an integer in the first element, a string in the second, a boolean in the third, and it's totally happy with that. Okay? Most languages are not happy with that. Okay? In Python, you actually don't even declare how many items are there. Okay? It will just let you put as many in as you want. That's special. Yes, if you know, it's actually not an array, but we're just going to assume it's array. We're going to talk about what the heck Python's really doing in a couple classes. Okay? So in Python, this is how you would declare an array. Once you have an array, then you can add stuff to it. Okay? In Python, you use this append. So you use the array's name and you say dot append and you tell it what you're going to append or add into it. So if I'm going to add in 5 items, I'm using a range from 0 to 5, I'm using a loop. I'm going to ask the person for the thing. I'm going to hold it in this single variable, and then I take the single variable and I add it to my list or array. And then I keep looping around 5 times. Okay? If you were a C programmer, you would still have the loop, just like we do normally. You're grabbing the information, but notice you use the index. So this counter is starting at 0 and goes to 4, 0 to 4, so 5 items in total. And you get the value from the person doing it, and you take it and you assign it to the array at a specific index. Okay? So Python uses append. Most other programming languages don't use append. They use things like this. So if you were a JavaScript programmer, it would be update. Oh, I don't have that one. Do I have the C++ version? Yep. So C++, you can see, is the same kind of thing. Okay? So that is putting the information into an array. Once I have the information in the array, can I print it out? Well, absolutely. So here's a loop again. Here is a counter. Here is my array, and I'm referencing a single element at a time. So remember, this is going to go from 0 once again to 4. So just to see this in action, here's the exact same code. I'm just going to put a breakpoint there and step through this. Okay, so this is where the array is getting created. So you'll see here it is here. And in Python, you don't have to say how big it is. Okay? Once again, that's unusual. Most programming languages you would have to. And then we're just going to loop around and we're going to ask for a percentage in this case. So say the person got 99. So you'll see that single variable now is 99. So we're going to look to see what's happening here with our array. We're going to take that value and we're going to append it to student marks. And you'll see there it is there. Now we're going to get another value. And we're going to append it and see how it added it in. Okay, so append just takes it and sticks it at the back. So it's just going to keep doing this over and over again. 77, whoops, I want to do 66. Okay, and then you can see in your IDE, there are my 5 items. This is the 0th, 1st, 2nd, 3rd, and 4th. Okay, so now I'm going to have another loop. Once again, I'm going to start at 0, and notice this time I did not say, I didn't hard code 5. So once you actually have an array, when you're looping over it, it's really bad idea to hard code the ending point. Because someone might in the future come through here and say, no, we actually don't want 5 marks, we want 15. But if you change it here, but forget to change it here, your program's not gonna do what it's supposed to, okay? So every time after you actually create your array, never hard code how many elements are in it. Notice we have this lovely function called length. The array can tell you how big it is. And you can see that because over here, remember this started at 0 and it updates as we add things, this auto updates. So the array knows how many elements are there. Once again, notice it's 5, not 4. We count them 0 through 4, but there's actually 5 in total. Okay, so we're going to start with this element right here. So I'm just going to add this to a watch. Okay, and we're going to step through. There's the first one, so we're going to pick out the 99 and print it out. Now we're going to come back and notice it's switched. Okay, now it's 88 because our counter is 1. This is the first element. And it's just going to go through and print them all out. When it's done, it'll just hop out. Okay, so that's how Python deals with adding things into an array and looping over them. Now, not all programming languages are like that. C is very different, and most languages function more like a C-type thing than a Python. So notice we're taking our array and we have to hard code and tell the computer in advance, reserve 5 spots in memory to put these things in. Because notice I'm then reserving this afterwards. So I'm reserving 5 spots, and then in the next location, I'm actually reserving this thing. Okay, so the computer has to keep track of where all these are. I'm just going to put a breakpoint there. Hopefully this will work stepping through it. There we go. Okay, so here we are. We reserve this. What is going to be in those 5 spots in my C program? If I open this up, what should I see? Anyone? So in the Python version, it was empty. What should I see in C? No one wants to guess?
0 to 4.
So it should see 0 to 4, and what will be in the values?
5.
So in each value, there will be 5. So there should be 5 slots, right? What are these values going to be at the very beginning? Just random garbage. And remember that. Okay? It just took those memory locations and said, okay, I'm now going to name them something so I know what they are. But in C, there's just random garbage floating around in there. As you can see, there's 2 zeros, a minus number, and a really big positive for some reason. Okay? So remember that. Many programming languages do not help you out and put like zeros in there. Most people would think that there'd be zeros in there. Python, there was nothing. There wasn't even those 5 slots because it created them as we needed them. But there's just garbage floating around in here, okay? So don't forget that. And look, this variable here, it's this weird number here, okay? Like what the heck is that thing? So now we're gonna go through and we're gonna get from the user 5 items, and we're going to actually assign them. So we're gonna put like real numbers in here, okay? So we're gonna go through, let's do this. So same kind of thing, we'll get 99. Okay, and then we'll assign it in. So notice now the value is really there. Okay, so as we go through, it actually puts it in. But there's just garbage floating in there until we actually put something in there. Okay, so now we can see we actually have real data. Now what we're going to do is we're going to do the exact same thing, and we're going to go through and print those values out. Now, in C and many programming languages, it's a little more complex to get the length of the array. So size of doesn't return how many items there are, it returns the size of the memory location. And remember, I made this thing in integer. Okay? So what size of this thing, my entire array, is actually 20. It's 20 bytes because each element is four bytes. That's what it's actually holding. Okay? So if I say size of this array, it's how many bytes it's actually holding. So to get the size of the number of elements, I take the size of the entire thing and I divide it by the size of just one of them. Okay? So how many bytes is the whole thing taking up? Divided by how many bytes a single thing is taking up. And this is nice and universal. It doesn't matter if it's an integer, a float, a string, whatever, because they all have to be the same type in C. The entire size divided by one element will always get me how many elements there are. Okay, so if we step through this, length of array, you will notice now, is 5. Okay, and then we have our loop, and we're indexing a single element at a time, and we just go through and print it all out. There we go, prints them all out.